Hello everyone. Today we are going to discuss about the data communication subject and what are the first module, what are the topics it's going to cover and all those stuffs. Let us see firstly the outline of it, why we should study all the stuffs, and then let's move on to the in-depth, let's dive into the concepts, right? So first of all, so what is data communication, why we need all those stuffs, that will be covered in 1.1. Then we'll go with the network types, internet history, standards, and the administration. Generally in this, what is actually gonna introduced is the concepts of the data communication and networking. We'll be discussing about the data communication components, data representation, data flow, and how the structure of the networks is moving and that carry the data. We can also discuss about the network topologies, categories of the networks, and the general idea behind the internet. Internet is a very important concept, and what are the aspects involved in that is also important. So also the protocols and the standards, it gives you the quick overview of the organization and also the standards in that the data communication and networking happens. So now let us move on to the get to know first of all what is data communication and so on. Okay. Before discussing about the data communication, first of all, what is communication? Why we need to communicate? We have to communicate because we're going to want to share something, share a message or share some information so that the other person will understand what we are trying to tell our emotions or something else like that. It's basically it's about the sharing the information, right? So when we communicate, we are sharing the information. So this sharing, it can be either face-to-face communication or it can be local or remote. So basically, when we are going to do using the telephone, tele means what distance, right? From the distant, if we are communicating, that comes under the category of telecommunication, which involves telephone, telegraph, television, communication at a distance. That is what we mean. However, that is different from the our data communication. Data communication is nothing but exchanging of the data. We are going to exchange the data between two devices. It's not about face-to-face communication. It is about the two devices, how they are going to communicate with each other via some form of the transmission media. So, see, separately, if they are not connected, how they will communicate? Communication will happen if the connection is present, right? So, how the exchange of the data will happen when some form of the transmission media is evolved in between the two devices. Then, let us decode the data, what is communication, then what is data communication, and so on. It is one of the interesting topic. Okay, so basically what is data? Data is nothing but it is a information that is present any form. Okay, see, unless I give the data and the other person is understanding, doesn't matter whether it is in the form of emojis, text, audio, video, images, so on, even symbol signs, anything it can be. Okay, anything is possible, and that is agreed upon the parties. Okay, creating using the data. Now we have to know what is data communication. Data communication is nothing but what? Exchange of the data between the two devices via some form of the transmission medium. So the transmission medium can be such as a wire cable. Okay. Second, next point is, for data communication to occur, what happens actually is communicating device must be a part of communication system. That is, say, if it is not working, malfunctioning is happening, or it is not flexible with our communication system, then that doesn't come under the data communication. It should be a part of our communication system. Communication system is made up of the combination of both, whether it is hardware only or software only. No, it is completely evolved with the combination of the hardware and as well as the software. Now, what are the fundamental characteristics of the data communication? See, now, data communication to happen, we need some characteristics, right? What are all the important aspects that has to be met? What are the basic agenda has to be met? So we have some standards, right? This has to be met. Similarly, even in data communication, we have some features that have to be met. Okay, for that, what are the basic things that has to be met is delivery, accuracy, timeliness, jitter. Delivery is nothing but delivery data to the correct destination. See, if I'm giving a data, and if the concerned right person has to be reached, right? If it is going to the some other wrong person, then that is not a part of a data communication. It has to go and deliver the data to the right and correct destination itself. Accuracy. So accuracy means the data should not be altered. Okay, whatever the data, the original data should not be altered because of the communication. Right from the beginning, the first person is telling something. By the time it reaches the 11th person, data is altered. Then that becomes adulteration, right? So it should not happen in that way. The data should be accurately delivered to the concerned person. So in that cases, what we are going to do is, we have to maintain the fundamental characteristics of the data communication, and in that the one of the important aspect is accuracy. Timeliness, delivery the data in timely manner. So if my data has to be delivered today and the data is going to deliver next month, it's of no use. What if it is timely sensitive? If it is very urgent information that cannot be utilized after a month, so on time it has to be delivered. Jitter refers to the variation in packet arrival time. So suppose you imagine a message that is divided, whole data is that's of big size, that is divided into smaller parts, part 1, part 2, part 3. And for example, let us take a movie. Okay, part 1, part 2, part 3, if at all. Part 1 is played, part 3 the climax is played, then the middle part. Does it make sense? No, right? So the variation in packet arrival time should not be a problem for our message to be delivered. The right information in the right format, in the right person, at the right accuracy level, in a timely manner, it has to be arrived. That are the fundamental characteristics of the data communication. So for the fundamental characteristic of the data communication is nothing but delivery, accuracy, timeliness, and jitter. You can remember it is DAT, TAD-J or DAT-J. Okay, DAT-J is fine. Nextly, let us see the components of the data communication. In the components of the data communication, we have 5 important components that comprises our data communication system. What are those? The 5 components of the data communication is nothing but the sender, receiver, message, protocol, and transmission medium. So we came across all this. So this diagram is important when you're writing the answers. Okay. So sender, receiver, message, transmission. For that message to transmit, you need one transmission medium and a protocols. So let us see what are those stuffs. Components on message. Data of the informations can be to be communicated. The message can be anything of our choice, right? It can be text, numbers, image, audio, or video. Do you think text is a message? Numbers is a message? Image is a message? Audio is a message? Video is a message? Anything that conveys something is nothing but our message. Nextly, sender. The one who sends the data is called as a sender. Here, the data communication happens between the 2 devices. Therefore, the device which sends the data message is called a sender, and the device that receives the messages is called as a receiver. Then transmission medium. So already we discussed that the transmission medium is nothing but it can be like a wired cable, right? So that can be like twisted pair cable, coaxial cable, radio waves, fiber optic cable, etc. Physical path by which the message is transmitted from sender to receiver. From sender to receiver, the message has to be transmitted. For that, we need one transmission medium. The transmission medium is nothing but our cable. The cable can be anything like twisted pair cable, coaxial cable, radio waves, fiber optic cable. Nextly, 5th point is very important. That is nothing but often we keep on hearing to this concept, that is nothing but our protocol. If we have listened, right, like president gave a protocol, CM has a protocol, so you have to meet the protocols. So what is protocol? Protocol is nothing but it is a set of rules. Set of rules, that keyword is important, okay? Set of rules that governs the data communication. So the data communication, all the parameters that has to be governed by the set of rules. It represents the agreement between communicating devices. Without a protocol, 2 devices may be connected but not communicating. Two devices may be connected, but it won't communicate if you don't have the protocol. So the protocol is important. Try to understand very importantly, connected but not communicated. Like we fight with our friend, maybe we are connected, but we won't communicate, right? Something like that. Nextly, data representation. Just now we saw how we can represent the data. The data can be represented in text, numbers, image, audio, video. In that detailing, we will see what is text, how the numbers are represented, how the image is represented, audio, video, and so on. First of all, text. Generally, text means is nothing but whatever the data we have in computer system, it is now nothing but in terms of the digital ones, right? It will be in terms of the zeros and ones. Zeros and ones, 0 or 1, right? So it is a bit pattern. The text also can be represented in a bit pattern. So in order to convey the message properly, we use this sequence of bits. Sequence is nothing but continuous number of bits. Different set of bit patterns have been designed to represent text symbols. So for example, for A we will have some bit pattern, for B we will have some bit pattern, and so on. This set is nothing but it is called as a code. We have some code to represent. For example, if I want to represent letter yes, that will represent some code. Okay, for that we have set of patterns. And the process of representing the symbol is called coding. So the concept is always we keep on thinking what is coding. It is nothing but how we are going to represent those symbols, how we are going to code it. That is nothing but the concept is called as a coding. Nextly, Unicode. Unicode is nothing but it uses the 32-bit. Generally, even for a single character, we use 32 bits to represent, or the symbol in any language in the world. We'll be discussing with in terms of the 32 bits. Also, we use the ASCII code. ASCII code is nothing but American Standard Code Information Interchange. Basic Latin. Basically, this is 7-bit code designed to provide the code for 128 symbols we are going to represent. Now constitutes first 127 characters in Unicode. So now we are going to discuss only about the 127. Before it was representing the 128 symbols. This is all about text. Text is nothing but, let us have a slight revision. Text is nothing but, see, any text patterns, any letters that we see can be represented in terms of the bits. Bit is nothing but 0 or 1. So if we want to discuss or if we want to represent any letters or any text, we go with the sequence of the bits. Okay, that sequence of the bits is that set. Okay, the sequence of the bits what we have, that is called as a code, and the process of representing that symbols is called as coding. In that we have many types of the coding patterns we have, and another the very important one is Unicode. In Unicode we use the 32-bit pattern to represent a character or a symbol in any language in the world. Let it be any language, it can be English, Kannada, Hindi, Telugu, etc. 32 bits is required for a single character to represent. Whereas in case of the ASCII, that is basic Latin, 7-bit code is represented, and generally it will give the code for the 128 symbols. Right now it is going to give for the Unicode first 127 characters. This ASCII code will be giving you the code. In Unicode, you need 32 bits to represent one single character. Whereas in case of the ASCII characters, 7-bit code is more than enough. Numbers. Like text, numbers also can be represented in bit patterns. Bit pattern is nothing but zeros and ones. So this number directly we are going to convert into a binary form. Binary is what? 0 and 1. To simplify the mathematical operations. By doing this binary form conversion, it will be easier for us to do the mathematical operations. Okay. Now let us see about the images. Even images are also, so the very first point, keep it in mind, text, audio, video, whatever it is, we can represent those things in terms of bit patterns. In images, the images is also represented in bit patterns. Images is composed of a matrix of pixels. Matrix is nothing but what? Combination of the rows and columns, right? It is a row cross columns. So the pixels is nothing. Pixels will tell you, it's like a small dot. Each pixel is a small dot that will represent you that image. So the size of the pixel depends on the resolution. Whatever the resolution you give, it depends on that particular size. So for the more clarity, you should have more good resolution. For the lesser quality, the lesser resolution is enough. For example, an image is divided into 1000 pixels. Now let us say one small image, let us take, okay. That small image, if you are dividing it into 1000 pixel or 10,000 pixel, that matters. In second case, better representation of the image. Because the more you divide it into a smaller pixels, the more the clarity or the visualization will be more enough, good enough. But more memory is needed to store the image. Remember, the more quality is good, but the memory is also important, will be needed highly because that much of data is there, right? Yeah. Nextly, each pixel is assigned a pattern. For every pixel we do have assigned a pattern. Size and value depends on the image. So the size, the value, it depends on the image. For example, now let us take about the black and white image. In black and white image, it is all about 1-bit pattern. 1 bit is more than enough to give a pattern to it. Okay. Example, chessboard. Grayscale can use 2-bit patterns. Color image RGB or YCM, intensity of the each color is measured and a bit pattern is assigned. So based on the intensity, we go with the two types. Either it can be RGB or it can be of the YCM. Okay. Now let us see about the audio and video. Audio is nothing but the sound effect, and this concept is nothing but we are going to discuss about the recording and the broadcasting of the sound or the music. It is continuous or not discrete, because it is there is no discontinuity. Continuously the sequence of the bit will take place. Video is the recording and the broadcasting of the picture or the movie. So that is how it happens with the video concept. Video can be the continuous, example the TV camera, entity of the or the combination of the image, or the discrete. Each discrete entity arranged to convey the idea of the motion. So this is all about the audio and video. Audio is the recording and the broadcasting of the sound or the music that takes place, and it is a continuous, not the discrete one. Video is the recording and the broadcasting of the picture or movie that can be taking place. In video, we do have the visual effects as well, and it can be discrete because it cannot be continuous, right? Because the continuity will be like, the fluctuation will be high, low, and so on. Data flow. This is very important concept in data communication. So how the data flows, either it is one-sided, two-sided, or not happening at all. So in data flow, we have three types of the communication, that is nothing but simplex, half duplex, full duplex. Okay, so this diagram is important. Simplex is nothing but direction of data flow will happen only one way. Okay, so mainframe computer, left side is a mainframe computer and right side is the monitor. Only this can go in one direction itself. Okay, and in half duplex it is like, first you communicate, then you stop, then I will communicate. It is like a half duplex. Okay, and once see the direction of the data at the time one, the person A is communicating with person B. At that point of time, the person B is not supposed to communicate. Whereas in case of the after the communication of there happens by the first person, then we'll go with the second person. In the second person, we'll be using the he'll be transmitting the data, so that the first person is quite enough now. So either you occupy the space or I occupy the space, but not the both. Whereas in the full data communication, it's not like that. It is bidirectional, and both the systems can communicate with each other at a time. So what are the data flow methods we have? It is simplex, half duplex, and full duplex. Nextly, networking. Networking is nothing but, so when the systems are connected, but still if they are not communicated, it's of no point, right? So for that we wanted the protocols. Whereas the networking is nothing but the devices which are not connected with each other, but still the interconnection of the devices happens. In such a cases, we will go with the networks. A network is nothing but it is an internet interconnection of a set of devices capable of the communication. So in this definition, the device can be a host such as a large computer, desktop, laptop, workstation, cellular phone, or security system. These are all the important It can be devices that can be hosting such as a large computer. It can be a desktop, laptop, workstation, cellular phone, or even the security system. A device in this definition can also be connecting device such as a router. So not only this, it need not to be it is a computer, desktop, laptop, or cellular phone. It can also be like a router, switch, modem, and also on. Even these are the devices that is going to communicate with each other once they are connected. So what are the network criteria we do have to utilize this feature? So the network must be able to meet a certain number of criteria. The most important of these are nothing but very three important factors are important: performance, reliability, security. How do they perform? What is performance? What is reliability? What is security? Let us discuss one by one. Performance. Performance is nothing but it is measured in many ways. First of all, it can be of two types. Firstly, it is transit time. Secondly, it is response time. What is transit time? Amount of the time required for a message to travel from one device to another. So transit time is nothing like traveling time. Okay. So how much time is required for one particular message to go from one system to the another system? Now let us see the second concept, that is nothing but the response time. Time elapsed between the inquiry and the response. So what is the time required for between the inquiry and the response, or how it is going to respond with each other? Nextly, we will be discussing all about the performance. Performance depends on the number of the users, medium, capability of the connected hardware, and the efficiency of the software. It is evaluated by networking the metrics. So in that also we do have the two important factors, that is nothing but the throughput and delay. In performance we have throughput and delay, whereas in case of performance measuring terms we do have transit time and the response time. Okay. So finally, let us discuss about reliability and security. Reliability is nothing but it is generally measured in terms of frequency of failure, time is taken to recover from the failure. Reliability is the what? How much, what is that? Though the situation is not right, how it is going to withstand or face the problems, right? So we'll say no, that is not that reliable or that is not that efficient. It cannot withstand the issues. Something like that. How much it can withstand the problems. Okay. So that is basically we are going to measure in terms of the frequency of the failure. We call it as FOF. Okay. Frequency of failure and time it takes to recover from the failure. So already failure happened. Now what to do? So how much time you will take to rebuild yourself? Security. So security is nothing but our data should be protected. Obviously, whatever the data the sender is sending, it should not be altered or it should not be adulterated. The data should be protected. Alright, protecting the data from the damage. No damage should happen to the data. Protecting the data from the unauthorized access. So it should not be, the data should not be accessed by the some other unauthorized person. It should be met or it should be delivered only to the legitimate users. Implementing the policies and procedures for recovering from breaches and data loss. This is a very interesting topic. So what are the policies we are going to implement and what are the procedures we are going to follow for recovery if breaches happen or the data loss happen, what we are going to do? All this comes under the category of the security. Okay, so nextly we will discuss about the physical structure. A network has two or more devices connected through the links. So we know that two devices are there, they'll be connected. How they will be connected? Through the link. So now we should know what is a link. Link is nothing but in a communication pathway that transfers the data from one device to the another. How we are going to link each other. For communication to occur, the two devices must be connected in some way to the same link at the same time. Same link it should have at the same time. At the same time also it has to be connected. So the link can be two types. What are that? Point to point and multi-point. What is point to point? See the types of connection. The link can be point to point and one more thing is multi-point. Point to point is nothing but one sender, one receiver. That is point to point. Multi-point is one sender, many receiver. That is See here. We do have 3 systems, right? One sender is there. Yes. So that is point to point and multi-point. So the way how we are connecting to each other, that is nothing but topology. In that we have the physical topology, refers to the way in which the network is laid out physically. Physically how they are connected to each other. Topology of the network is a geometric representation of the relationship of all the links and linking device to one another. So what is the link? We know that two systems are connected through the link. That link will transfer the data. Now, how the geometrically, so how the design is there, right? So the link, how it is connected with each other, that is nothing but so-called topology. Topology is nothing but a geometric representation of the relationship of all the links and linking devices nodes to one another. For example, now let us take one example. This is nothing but a fully connected mesh topology. Let us discuss about mesh topology in further upcoming sessions. Now, what is see? Now we have 5 systems. It is understood we have 5 systems. So each system is connected. How many links are required? So we need 10 links. Why? Bidirectional, right? Isn't it bidirectional? So 5 system means 10 links. 10 system means 20 links. So on. Now let us see what is mesh topology. Every device has a dedicated point-to-point link. First point you have to keep in your mind for the mesh topology is that it is dedicated point-to-point link to every other device. Dedicated means link carries traffic between only 2 devices it connects. Completely dedicated only to that particular 2 devices itself. It is not going to carry the data for some other devices. So dedicated means link will be carrying the traffic between only 2 devices it connects. To find the number of physical links in a fully connected, each node must be connected to every other node. So if you want to say it is fully connected or not, fully connected means every system has to be connected or it should be in touch with all other systems. Then only we call it as fully connected. So node 1 must be connected to n-1, node 2 must be connected to n-1, node n must be connected to n-1. What is this n-1? See, except me connecting to myself is of no point, right? So along with me, that -1 is nothing but it's me, okay? Separate me. All other nodes, whichever is present in our system, we have to be connected with each other. That's why it should be n-1 nodes. I repeat again, n-1 is nothing but, -1 is nothing but itself. No need to connect for ourselves, no need of self-looping. So the data has to be communicated to somebody else. So except me, all other nodes, whichever is present in our system, has to be connected. Therefore, it is n-1. So overall, how we can say is, we can tell it as in the form of n into n-1 physical links. If each physical links allows the communication in both the direction, then we can divide the number of the links by 2. So if it is communicating in both the ways, what we can say, we can divide it by 2 because both is what 2 is, right? So divided by 2, n into n-1 divided by 2 duplex mode links. That is, physical link is n into n-1. Duplex mode link is n into n-1 by 2. To accommodate many links, every device on the network must have n-1 I/O ports. So many links, to accommodate many links, every device on the network must have what? n-1 I/O ports. So what is the advantages of these mesh topologies? That is important. Advantages of this is dedicated link. So I know, say for example, the one particular node A is connected to node B, and if the message is not, data is not transferred, I can understand that there is some issue within node A, right? So the dedicated link will guarantee that each connection carries its data load. So it is very crystal clear that this particular node is going to take this kind of data. Robust. If one link becomes unusable, it does not incapacitate the entire system. So it is not an issue. Even if it is one is not usable, no, that's not an issue. We can go with some other things. Privacy or security, because messages carried along the dedicated link, physical boundaries prevent the others from gaining access to the message. So it is, since it is dedicated, when some other cannot come and peep into what is inside. So the privacy will be there, security will be there, fault identification and isolation is damn easy, because I know that this particular node is connected to this particular node itself. Node A is connected to node B itself. If the message is not transferred properly, I understand that there is an issue with the node A. So fault identification and isolation is easy. So if one node A is not connected properly, like it's not working properly, I can isolate it, right? Like I can make it nullified and work with other system. Easy often for the network operator to discover the location of fault and its causes and to find solution. So network operator, you won't find it difficult to to discover where the fault happened and what is the solution or what is the issue. For that, first you have to figure out, right, where is the fault. That will be easy for the network operator. First thing is dedicated link, point-to-point, robust, and security will be there, privacy is there, fault identification is easy to for the network operator to discover the location of the fault and also can easily give the solution for it and so on. But what are the disadvantages? Obviously, there should be some disadvantages for the mesh topology related to amount of cabling and number of I/O ports required. Installation and reconnections are difficult. If I want to do the installation or reconnection, something is going wrong, it will be very difficult. Bulk of wiring can be greater than available space. Since it is dedicated for each and every one, we should provide the wiring. Then that is also cost consuming, right? Hardware required to connect each link, I/O ports and cables are expensive. Therefore, it is very expensive. Bulk of wiring is required. Installation and reconnections are very difficult. These are all the issues that we are going to face in the mesh topology. For this reason, mesh topology is implemented in a limited fashion. So in practically, very few people will use this mesh topology. Okay. So let us see one practical examples we do have for the mesh topology is the connection of the telephone regional offices, in which each regional office need to be connected to every other regional office. So basically this mesh topology is used in the telephone regional office. So they will connect with each other only with that regional office. None others are entertained. Nextly, let us discuss about the star topology. Initially I thought it will be in terms of star. It's not actually. We do have one centralized connection that is called as an hub. Okay, point-to-point link will be there, and that point is nothing but we call it as an hub. All the systems will be having the dedicated point-to-point link to this centralized hub. So let us discuss about the star topology. Star topology, each device has the dedicated point-to-point link only to the central controller called hub. None other than, see in this diagram it is very clear. One system is not connected to the another system, right? It is connected directly only to the hub. That is what we are trying to discuss. So devices are not directly connected to one another. So even if I want, directly we are not connecting. One device will be connected to the hub, another is also connected to the hub. This device will go, data will be going to the hub and then to the another device. Controller acts as an exchange. So where the exchange of the data takes place means it takes place in the hub. If one device wants to send data to another, it sends the data to the controller, which then relays the data to other connected device. So if node A, if person A has to send the message, person B has to receive the message, it is not directly done. Person A and person B both will be connected to the hub. Person A will send the message, it will go to the hub, the hub will give the message to the person B. Again the person B will tell something, he will give to the hub and the hub will exchange the data, will transfer the data to the node A. Okay. It is something like one mediator we have. Directly we won't tell the message. We'll pass the message to the mediator. Okay. So what are the advantages? less expensive. Okay. What you need? All that you need is one hub. Systems, that's all. It is less expensive. Each device needs only one link and one IO port to connect to any number of device. So one person, so everyone is connected to hub, right? So one IO port is enough and one link is enough. Easy to install and reconfigure. Whereas in mesh topology it was difficult to install and reconfigure, right? Here it is easy. One more thing you keep in mind, whatever the disadvantages of one topology, that will be the advantage of the next topology. See, lastly we saw that it is more expensive, installation is difficult, reconfiguration is difficult. It's easier. Less cabling. Over there in mesh topology we had more cabling, right? Here less cabling. Addition, deletion, moving of the device involves only one link. One link is more than enough. Robustness, that is, if one link fails, only that link is affected. One link is failed, no issues, only that link will be affected. Okay, easy fault identification and fault isolation. Hub can monitor the link problems and bypass the defective links. So it can bypass the defective links and easily you can identify where it is going wrong. Disadvantage, by this we can get to know that everything is connected to hub. What if hub fails? Entire system is dead, right? That is the first disadvantage. If hub goes down, entire system is dead. As each node must be linked to hub, more cabling is required than bus and ring topology. Compared to mesh, this is fine. But compared to the bus and the ring, it requires more cabling. Generally, it is used in LANs. LAN is nothing but local area network. High-speed LANs use the star topology with centralized hub. So, if you want high-speed LAN and all, if you are using, for that we use the star topology with the centralized hub. Nextly, we are going to discuss is about the bus topology.